Hey there! How's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this with me for a moment. You're standing on the deck of a research vessel 200 miles southwest of Guam, staring out at what looks like perfectly ordinary ocean. The water sparkles blue-green under the tropical sun. Gentle swells roll past your ship, and seabirds dive for fish in the distance. It's beautiful, peaceful even. But here's what's absolutely mind-blowing. Directly beneath your feet lies the most alien place on our entire planet. A place so extreme, so impossibly deep, that it makes outer space look welcoming by comparison. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. What you're floating above is the Mariana Trench, Earth's ultimate abyss. And when I say ultimate, I mean it in every sense of the word. We're talking about a crescent-shaped scar in the ocean floor that stretches for 1,580 miles. That's longer than the entire east coast of the United States. It averages 43 miles wide, but here's where it gets really wild. It plunges nearly 7 miles straight down into the earth, 7 miles down. Let that sink in for a second. You know how when you're flying in an airplane, you look down at the ground from about 7 miles up and everything looks tiny? The cars look like ants, houses look like dots, entire cities shrink to miniature versions of themselves? Well, imagine that same distance, but in reverse. Straight down into crushing darkness where no human eye has ever seen sunlight. The ancient Chamorro people who navigated these waters for centuries had a name for this place. They called it the place where the world ends. And you know what? They weren't wrong. These master navigators, who could read currents and stars like we read street signs, sensed something profound here. Their fishing lines would disappear into what seemed like nothingness. The currents behaved strangely. The very water felt different. They knew they were at the edge of something beyond human understanding. But it wasn't until 1951 that we got our first real glimpse of just how right they were. The British survey ship HMS Challenger 2 was conducting routine depth measurements when their instruments started giving them readings that seemed impossible. 35,797 feet down. The crew double-checked their equipment, ran the measurements again, and got the same impossible number. Now, numbers like that are hard to wrap your head around, right? 35,000 feet, 2025. What does that even mean? So here's how the scientists put it in perspective, and this is where it gets absolutely crazy. You could take Mount Everest, the tallest mountain on Earth at 29,032 feet, drop it into this hole, and its peak would still be covered by over a mile of water. Think about that for a second. The tallest mountain on our planet would disappear completely into this underwater canyon, and you'd still have ocean above it. But here's what really gets me excited about this place. It's not just a big hole in the ground. This trench is literally a portal to an alien world that exists right here on Earth. We've been so focused on looking up at the stars, searching for life on other planets, that we've ignored the most extraterrestrial place we've got, hiding in plain sight beneath the waves. See, when people think about alien environments, they imagine the surface of Mars or the moons of Jupiter. But Mars? Mars is nothing compared to the Mariana Trench. The pressure on Mars is less than 1% of Earth's atmosphere. The Mariana Trench? The pressure down there is over 1,000 times what we experience at sea level. 1,000 times. If you were somehow transported to the bottom of this trench without protection, you wouldn't just die. You'd be compressed into a space smaller than a marble before your brain could even process what was happening. And the cold, we're talking about water that hovers just above freezing, 34 to 39 degrees Fahrenheit, in eternal darkness that makes the deepest cave look bright by comparison. No sunlight has touched the bottom of this place for 50 million years. 50 million years of absolute darkness. But here's where this story gets really incredible, and why I'm so excited to share this journey with you. For most of human history, we assumed nothing could live in such an extreme place. It was too deep, too dark, too cold, too crushing. Scientists called it the azoic zone, the zone without life. They were certain that below a certain depth, maybe a few thousand feet, the ocean was basically a liquid desert. They couldn't have been more wrong. The first hint that something extraordinary was happening down there came from those same Chamorro navigators I mentioned earlier. They told stories that European explorers dismissed as folklore, about strange lights in the deep water, about creatures unlike anything found in shallow seas. The navigators spoke of the deep as if it were alive, breathing, full of mysteries. And you know what? They were absolutely right. But we're getting ahead of ourselves. Before we meet the incredible creatures that call this abyss home, before we follow the brave humans who dared to descend into this alien realm, we need to understand how this place came to exist in the first place. Because the Mariana Trench isn't just sitting there, it's alive, growing deeper every single day, carved by forces so massive they're reshaping our entire planet. The story begins 50 million years ago, when our planet looked very different than it does today. Picture the Pacific Ocean, but imagine the seafloor as a living, moving thing, because that's exactly what it is. The Earth's crust isn't one solid piece. It's broken up into massive plates that float on top of molten rock, constantly moving, colliding, and grinding against each other like ice flows on a frozen river. 50 million years ago, two of these massive plates, the Pacific Plate and the Philippine Plate, began what can only be described as the slowest motion collision in Earth's history. The Pacific Plate, older and denser, started sliding beneath the younger Philippine Plate at a rate of about 3 inches per year. 3 inches per year. Aye, that's slower than your fingernails grow. But when you're dealing with pieces of the Earth's crust that are thousands of miles across and dozens of miles thick, even tiny movements create forces beyond imagination. The descending Pacific Plate didn't go quietly. It bent under the enormous pressure, buckled like a piece of metal being forced into too small a space, and finally began to crack. That crack, that wound in the ocean floor, became what we now know as the Mariana Trench. And here's what's absolutely wild. This process is still happening right now. Right now, as you're listening to this, the trench is growing imperceptibly deeper. Every earthquake in the region tells the story of rock grinding against rock, of our planet literally reshaping itself in real time. The Mariana Trench isn't some ancient geological artifact, is non the cos. It's a living scar on the Earth's surface, constantly changing, constantly growing deeper and more extreme. What makes this particular trench so special isn't just that it's deep slide. There are other ocean trenches around the world. What makes the Mariana Trench unique is the angle at which the Pacific Plate is diving beneath the Philippine Plate. Here, the Pacific Plate doesn't slide at a gentle angle. It plunges almost straight down, creating walls so steep they defy imagination. In some places, the seafloor drops 29,000 feet over just a few miles horizontally. That's steeper than the steepest mountain face on Earth. The result is a landscape that's more alien than anything science fiction has ever imagined. Picture underwater cliffs that stretch for miles, dropping into darkness so complete that the concept of dark loses all meaning. Imagine valleys so deep that if you could drain all the water out, they would dwarf the Grand Canyon. Picture rock formations sculpted by pressure so intense it would turn diamonds to dust. And in this impossible place, in conditions so extreme that they challenge our very understanding of what life can endure, something incredible happened. Life didn't just survive, it thrived. It evolved. It created forms so bizarre, so perfectly adapted to crushing pressure and eternal darkness, that discovering them has been like making contact with beings from another world. The creatures living in the Mariana Trench have evolved in complete isolation for millions of years. They've never seen sunlight, never experienced weather, never felt the touch of wind or waves. They exist in a world where the only law is pressure, crushing, relentless pressure that would obliterate any surface-dwelling creature in milliseconds. Yet somehow, impossibly, they've not just learned to survive in this alien environment, they've learned to flourish in it. And when we finally built the technology to visit their world, what we discovered changed everything we thought we knew about life on Earth. But those discoveries, the incredible creatures, the brave humans who risked everything to reach this alien realm, the mind-bending revelations that are still reshaping our understanding of our planet, those stories are still to come. For now, I want you to hold on to this image, somewhere beneath the Pacific Ocean, deeper than mountains are tall, lies a world so extreme and so alien that it makes the surface of Mars look like a tropical vacation. A world of eternal darkness and crushing pressure, where the very concept of up and down loses meaning. A world where life has written its own rules and created forms so extraordinary they seem like they belong in the pages of science fiction. This is the Mariana Trench. This is the place where the world ends and another world begins. And tomorrow, we're going to take you there. But first, we need to understand exactly how alien this place really is. We need to make the journey ourselves, from the sun-dappled surface of the Pacific down into the crushing depths where sunlight has never penetrated and pressure becomes a living force. We need to experience what it feels like to leave our world behind and enter a realm where the laws of physics become weapons and life itself becomes an act of defiance against the impossible. Are you ready for that journey? Because I promise you, once you understand just how extreme this place really is, once you grasp the full magnitude of what life has accomplished in the deepest corners of our planet, you'll never look at the ocean the same way again. You'll never look at life itself the same way again. The Mariana Trench is waiting. The abyss is calling. And the most incredible story on our planet is about to unfold. Welcome back. I hope you're as fascinated by this journey as I am, because today we're going to witness the birth of the deepest place on Earth. And I mean that literally. We're going to watch the Mariana Trench come alive, carved by forces so massive they're still reshaping our planet today. Now, I know what you might be thinking. How do you watch something that happened 50 million years ago? How do you witness the birth of something that took longer to form than humans have existed? Well, here's the incredible thing about the Mariana Trench. It's still being born. Right now, as you're listening to this, the forces that created this abyss are still at work, still grinding away, still pushing the boundaries of what seems possible on our planet. Let me take you back to where this all began. Picture the Pacific Ocean 50 million years ago. The water looks the same, that endless blue stretching to every horizon. But beneath the surface, the sea floor is engaged in the slowest motion collision in Earth's history. We're talking about two pieces of the Earth's crust, the Pacific Plate and the Philippine Plate, each one thousands of miles across and dozens of miles thick, moving toward each other with unstoppable force. Now, when I say they're moving toward each other, I don't want you to picture some dramatic crash. This isn't like two cars colliding. This is more like watching continents dance in ultra-slow motion. The Pacific Plate is creeping toward the Philippine Plate at about 3 inches per year. 3 inches. That's slower than your hair grows, slower than erosion carves through rock, slower than almost anything else you can imagine. But here's what's absolutely mind-blowing about this. When you're dealing with forces this massive, when you're talking about pieces of the Earth's crust that weigh more than entire mountain ranges, even the tiniest movement generates power beyond human comprehension. Every single inch of movement represents forces equivalent to millions of nuclear bombs. The Pacific Plate, being older and denser, began what geologists call subduction. It started sliding beneath the younger, lighter Philippine Plate. But this wasn't some smooth, gentle process. Picture trying to slide a massive piece of metal under another piece of metal, while both are under tremendous pressure. The Pacific Plate began to bend, to buckle, to deform under the incredible stress. And then something extraordinary happened. The plate didn't just bend, it cracked. Not all at once, but over millions of years, the stress became too much. The descending plate fractured along its leading edge, creating a wound in the ocean floor that would become the deepest scar on our planet. What's incredible is that this process is still happening today. Every earthquake in the region, and there are thousands of them every year, tells the story of rock grinding against rock, of our planet literally reshaping itself in real time. The Mariana Trench isn't some ancient geological artifact sitting quietly on the ocean floor. It's alive, dynamic, growing deeper and more complex with each passing year. Let me give you a sense of just how active this place is. The Pacific Plate is still diving beneath the Philippine Plate at that same steady rate, DA, 3 inches per year. That might not sound like much, but over geological time, it adds up to something extraordinary. In the 50 million years since this process began, the Pacific Plate has descended roughly 6,200 miles into the Earth's interior. 6,000 miles. That's nearly the radius of our entire planet. But the formation of the trench created more than just one deep spot. The subduction process sculpted an entire system of abyssal valleys and underwater mountains. At the southern end, you've got Challenger Deep, the deepest point we know of, plunging down 35,856 feet below sea level. But that's just one part of a much larger system. There's Serena Deep, nearly as profound, stretching for miles along the trench floor. There are underwater cliffs that drop for vertical miles without a break, creating walls steeper than anything found on the surface of our planet. There are valleys within valleys, each one carved by the relentless grinding of tectonic forces over millions of years. What makes the Mariana Trench unique among all the ocean trenches in the world isn't just its depth, though it is definitely the deepest. What makes it special is the angle at which the Pacific Plate is diving beneath the Philippine Plate. In most subduction zones around the world, plates slide under each other at room, relatively gentle angles, maybe 30 or 40 degrees from horizontal. But here the Pacific Plate is diving almost straight down, at angles approaching vertical in some places. The result is a trench with walls so steep they defy imagination. Picture this. In some areas, the seafloor drops 29,000 feet over a horizontal distance of just a few miles. That's steeper than the face of El Capitan in Yosemite, steeper than the walls of the Grand Canyon, steeper than almost any cliff face you can find on dry land. The geography that results from this process is unlike anything else on Earth. If you could somehow drain all the water from the Pacific Ocean and stand at the edge of the Mariana Trench, you'd be looking into a chasm that would make the Grand Canyon look like a shallow ditch. The walls would disappear into darkness far below you, dropping for miles and miles until they vanished beyond the ability of your eyes to follow. And here's something that really gets me excited. We're still discovering new features in this system all the time. In 2019, explorers found new pools of liquid sulfur at depths we'd never seen them before. In 2021, they discovered underwater waterfalls, places where super-dense water cascades down the trench walls like liquid mercury, creating flows that dwarf any waterfall on the surface. Every new dive, every new mapping expedition reveals complexity we never expected. There are underwater canyons that branch and merge like river systems. There are isolated basins cut off from the main trench, each one developing its own unique ecosystem. There are seamounts, underwater mountains, rising from the trench floor, creating islands of different pressure and temperature in this abyssal landscape. But perhaps the most remarkable thing about the formation of the Mariana Trench is what it tells us about the power and dynamism of our planet. We tend to think of the Earth as solid, stable, unchanging over human timescales. We build our cities and plant our crops and live our lives as if the ground beneath our feet is permanent and reliable. The Mariana Trench tells a different story. It's a reminder that our planet is alive, constantly changing, driven by forces so immense they operate on timescales we can barely comprehend. Every earthquake that shakes the region, every volcanic eruption in the nearby island chains, every measurement that shows the trench growing deeper, they're all part of the same incredible process that's been reshaping our world for millions of years. And this process is far from over. The Pacific Plate continues its relentless journey into the Earth's interior. The trench continues to deepen. New fractures appear in the descending plate, creating new valleys and new abyssal depths. Scientists estimate that the Mariana Trench will continue growing deeper for tens of millions of years to come, eventually reaching depths that will make today's record-breaking measurements look shallow by comparison. Think about that for a moment. The deepest place on Earth today, a place so extreme it makes Mars look welcoming, is just the beginning. The forces that created this abyss are still at work, still carving deeper into our planet, still creating new extremes that will challenge our understanding of what's possible. But there's something else about the formation of the Mariana Trench that absolutely blows my mind. The same forces that created this ultimate abyss also created the conditions that would allow life to flourish in ways we never thought possible. The grinding of tectonic plates doesn't just create deep trenches, it creates chemical gradients, temperature differences, and energy sources that life can exploit. The descending Pacific Plate carries with it organic matter, sediments, and chemical compounds that get concentrated and transformed under the extreme pressure and temperature conditions deep in the trench. Volcanic activity along the plate boundaries creates hydrothermal vents that spew superheated water, rich in minerals and chemicals. The constant seismic activity creates fractures and fissures that allow these chemical-rich fluids to percolate through the seafloor. The result is an environment that, while incredibly hostile to surface life, provides exactly the right conditions for organisms that have evolved to thrive under extreme pressure and in the absence of sunlight. The very processes that make the Mariana Trench so alien and forbidding also make it a cradle for some of the most extraordinary life forms on our planet. And here's what really gets me excited about all this. We're just beginning to understand how these geological processes connect to the biology of the deep ocean. Every new discovery about the formation and ongoing evolution of the Mariana Trench reveals new possibilities for life, new ecological niches, new ways that organisms can adapt to conditions that seem impossible. The Mariana Trench isn't just the deepest place on Earth. It's a window into the fundamental processes that drive our planet, a laboratory where the most extreme conditions on Earth create opportunities for life to push the boundaries of what we thought was possible. Tomorrow, we're going to make the journey down into this incredible abyss. We're going to experience firsthand what it means to leave the world of sunlight and surface pressure behind and enter a realm where the very laws of physics become forces of crushing destruction. We're going to feel the pressure building with every foot of descent, watch the last traces of sunlight fade into eternal darkness, and discover what happens when you venture into the most extreme environment our planet has to offer. But before we take that plunge, I want you to appreciate the incredible forces that created this place. 50 million years of tectonic grinding, 50 million years of the Earth reshaping itself on a scale that dwarfs human comprehension. 50 million years of our planet, creating conditions so extreme they exist nowhere else in our solar system. The Mariana Trench is more than just a deep hole in the ocean floor. It's a testament to the awesome power of geological forces, a demonstration of what happens when an entire planet becomes a laboratory for the most extreme conditions imaginable. And somehow, impossibly, it's become home to life forms so extraordinary they seem like visitors from another world. Are you ready to meet them? Welcome back to our journey into Earth's ultimate abyss. Today, we're going to do something that only a handful of humans in history have ever experienced. We're going to descend into the Mariana Trench, and I want you to really feel this journey with me, because what we're about to experience together is a passage from our familiar world into something so alien, so extreme, that it will change how you think about our planet forever. So picture this. You're sealed inside a specially designed submersible, essentially a titanium sphere surrounded by systems that barely, just barely, keep you alive in conditions that would obliterate any unprotected human in microseconds. You're sitting on the surface of the Pacific Ocean, 200 miles southwest of Guam, looking up at blue sky and feeling the gentle roll of surface waves. Your journey begins in sunlight. The water around you sparkles that gorgeous tropical blue-green, so clear you can see down maybe 150 feet before the ocean fades into that mysterious deep blue that hints at the profound depths below. Fish dart around your vessel, familiar fish, the kind you might see while snorkeling in the Caribbean or Hawaii. Everything looks normal, peaceful, exactly what you'd expect from the world's largest ocean. Then you begin your descent. Within the first 100 feet, something remarkable happens to the water around you. That brilliant tropical blue begins to change, deepening and darkening as you leave the sun-drenched surface layers behind. By 300 feet, the blue has become something richer, more mysterious. By 600 feet, you're entering what marine biologists call the twilight zone, and the water around you has transformed from that cheerful Caribbean blue to something that looks more like liquid indigo. This is where things start to get really interesting, because you're entering a realm that most life on Earth never experiences. The pressure at 600 feet is already 19 times what you feel at sea level. If you were somehow exposed to this pressure without protection, your lungs would collapse instantly, like someone stomping on empty paper bags. But your submersible keeps you safe, maintaining the comfortable atmosphere of pressure you're used to while the ocean around you becomes increasingly hostile. By 1,000 feet, something profound happens. The last traces of blue fade away entirely, replaced by a deep, rich green that seems to glow from within. This is scattered sunlight, the very last photons of surface illumination fighting their way down through the water column. At 2,000 feet, that green becomes darker, more mysterious. At 3,000 feet, it's barely perceptible. And then, at 3,200 feet, something incredible happens. The last photon of sunlight vanishes forever. Think about that for a moment. You've just crossed a boundary that divides the Earth into two completely different worlds. Above you lies the world of light, the world where photosynthesis is possible, the world where plants can grow and surface creatures can thrive. Below you stretches a realm of absolute darkness that has existed unchanged for hundreds of millions of years. You are now entering what scientists call the bathyal zone, and everything about your environment has become profoundly alien. The water temperature, which was probably in the comfortable 70s or 80s at the surface, has plummeted to just above freezing, 34 to 39 degrees Fahrenheit. And here's the crazy part. It's going to stay at that bone-chilling temperature whether you descend another 1,000 feet or another 30,000 feet. But the pressure is where things get really wild. Every 33 feet you descend, the pressure doubles. At 1,000 feet, it's 30 times surface pressure. At 3,000 feet, it's 91 times what you experience at sea level. Your submersible's hull, Rieseblocker, probably 6 inches of specialized titanium, is starting to compress noticeably under the immense forces pressing in from all sides. As you continue your descent, you start to notice something strange falling past your windows. At first, you might think it's snow, these white, fluffy particles drifting down through the darkness like a gentle snowfall. But this isn't frozen water. This is what marine biologists call marine snow, a constant drift of death from the world above. Every flake of this bizarre snow is made up of dead plankton, fecal pellets from surface creatures, fragments of decomposing fish, bits of algae, and organic debris from the sunlit world far above. It's the only source of nutrition for most life in the deep ocean, and it falls constantly, 24 hours a day, like a gentle rain of mortality that takes weeks to settle from the surface to the deepest depths. At 5,000 feet, you cross another boundary, and you're now deeper than most of the ocean floor. 90% of the seafloor lies above you. You're descending into a realm that represents less than 10% of the ocean's area, but contains some of the most extreme environments on our planet. By 10,000 feet, the pressure around you equals 304 times what you feel at sea level. A styrofoam coffee cup, if you could somehow expose it to this pressure, would shrink to the size of a thimble. Your submersible, even with its incredibly thick walls, has compressed noticeably. A sphere that was 6 feet across at the surface might now be 5.5 feet across. At 13,000 feet, you enter what scientists call the abyssal zone. This is where the ocean gets serious about being alien. The pressure is now nearly 400 times surface pressure. The temperature has stabilized at that bone-chilling 34 degrees Fahrenheit, and the darkness is so complete that it has its own quality, its own presence. This isn't just the absence of light, this is darkness as a physical thing, pressing in around you with almost tangible weight, but you're not even halfway to the bottom yet. At 15,000 feet, strange things start happening to the water itself. The immense pressure begins to change the very structure of the H2O molecules around you. Water, which we think of as incompressible, actually gets squeezed into a denser form under these extreme conditions. The ocean around you is becoming something that would be barely recognizable to surface chemistry. By 18,000 feet, you're experiencing pressure equivalent to 600 times what you feel at sea level. The marine snow continues to fall past your windows, but now it's joined by something else. Occasionally, a bioluminescent creature drifts by, glowing with its own internal light. These are some of the few sources of illumination in this abyssal realm, creatures that make their own light in a world where external light sources simply don't exist. And then, at 19,686 feet below the surface, you cross the most significant boundary in the ocean. You enter the Hadal zone, named for Hades himself, the realm of the dead in ancient Greek mythology. This is a zone so extreme, so hostile to life as we know it, that until 1956, scientists were convinced nothing could survive here. They were spectacularly wrong, but we'll get to that amazing story in a moment. In the Hadal zone, pressure becomes a crushing, omnipresent force that transforms everything about the physics of existence. At 20,000 feet, you're experiencing pressure equivalent to 607 times surface pressure. At 25,000 feet, it's 759 times. At 30,000 feet, it's 911 times what you feel at sea level. You're submersible, engineered to withstand these incredible forces, groans and creaks around you. The titanium hull continues to compress, and you can actually hear it happening. Sharp pops and clicks as the metal adjusts to forces that would crush any surface structure like an empty soda can. At 35,000 feet, as you approach the deepest parts of the trench, the pressure around you equals 1,086 times what you experience breathing air at sea level. Think about that number for a moment. 1,000 times. If you were somehow exposed to this pressure, you wouldn't just be crushed. You would be compressed into a space smaller than a marble before your nervous system could even register what was happening. The water around you has become something that barely resembles the familiar liquid you know from the surface. Under this immense pressure, water becomes significantly denser, and its properties change in ways that challenge our basic understanding of chemistry and physics. The very medium you're moving through has been transformed by forces so extreme They create conditions found nowhere else in our solar system. But here's what absolutely blows my mind about this descent. You haven't just traveled 7 miles down, you've traveled through time itself. The water you're now surrounded by hasn't seen the surface for hundreds, maybe thousands of years. Some of the water in the deepest parts of the ocean has been isolated from the surface world for centuries, carrying chemical signatures from long-dead civilizations, and the temperatures down here tell their own incredible story. While most of the deep ocean hovers at that consistent 34 to 39 degrees Fahrenheit, the very bottom of the Mariana Trench is actually slightly warmer, heated by the Earth's interior and by the friction of grinding tectonic plates. The bottom of the deepest place on Earth is warmed by the planet itself, creating temperature gradients and chemical conditions that exist nowhere else. As you approach the seafloor of Challenger Deep, something magical happens. Your lights, the first artificial illumination this place has seen since the last human visit, begin to reveal a landscape that defies every expectation you might have had about the bottom of the world. The seafloor here isn't barren rock or empty sediment. It's covered with a fine layer of that marine snow we've been watching fall during our entire descent, accumulated over thousands of years into a soft, pale carpet that preserves the history of the surface world in its layers. Every inch of this sediment contains the story of life and death from the sunlit world above, compressed and concentrated by the immense pressure into a record of our planet's biological activity. But that's not all. The seafloor is dotted with rocks, not ordinary rocks, but chunks of the Earth's interior that have been squeezed up from unimaginable depths by the tectonic forces that created this place. These rocks have never seen sunlight, never been exposed to the surface chemistry that shapes most of our planet. They're pieces of inner Earth, squeezed like toothpaste from the grinding collision of tectonic plates, and scattered across this alien landscape, something that would have seemed impossible just 70 years ago. Signs of life. Not just microscopic bacteria, though there are plenty of those, but visible, complex organisms that have not just survived in this crushing environment, but have thrived here, evolving into forms so strange and wonderful that they seem like visitors from another planet entirely. The descent into the Mariana Trench isn't just a journey through space, it's a journey into an alien world that exists right here on our own planet. A world where the familiar rules of temperature, pressure, and light have been replaced by extremes that challenge our understanding of what life can endure. From the sun-dappled surface to the crushing depths of Challenger Deep, you've traveled through a gradient of conditions more extreme than the difference between Earth and Mars. You've witnessed the transformation of familiar ocean water into something that barely resembles the liquid you know from the surface. You've passed through zones of eternal darkness, where the only light comes from the creatures themselves. And now, at the bottom of the world, in conditions so extreme they make outer space look hospitable, you're about to meet some of the most extraordinary life forms our planet has ever produced. Are you ready to discover what lives in the most impossible place on Earth? Welcome back to the bottom of the world. We've made our incredible descent through 7 miles of crushing ocean, and now we're here, at the deepest, most alien place on our planet. The pressure around us could obliterate any surface creature in milliseconds. The temperature hovers just above freezing, and no ray of sunlight has touched this place for 50 million years. Logic tells us nothing should be able to live here. Science textbooks from just 70 years ago insisted nothing could live here. But as our lights sweep across the seafloor of Challenger Deep, we're about to witness one of the most incredible stories in the history of life on Earth. Because this place, this impossible, crushing, freezing abyss, is absolutely teeming with life. Let me introduce you to some of the most extraordinary creatures our planet has ever produced, starting with something that completely rewrote our understanding of what's possible for complex life. Swimming past your submersible's window at 27,000 feet below the surface, deeper than Mount Everest is tall, is a fish. Not a microscopic organism, not a simple bacteria, but an actual fish with fins and gills and a backbone, navigating through water where the pressure would turn a human being into something smaller than a marble. This is a snailfish, translucent, ghostly, looking almost like a living piece of ice drifting through the eternal darkness. When scientists first spotted one of these incredible creatures in 2014, they literally couldn't believe what they were seeing. Fish aren't supposed to exist at these depths. The pressure should make it impossible. But here's where this gets absolutely incredible. This snailfish has evolved solutions to problems that would stump our best engineers. You see, most fish have something called a swim bladder, essentially an internal balloon that helps them control their buoyancy. At the crushing pressures of the deep ocean, that balloon would implode instantly, like popping a soap bubble with a sledgehammer. So the snailfish simply got rid of it entirely. No swim bladder, no air-filled spaces anywhere in its body. Instead, its tissues are held together by specialized proteins that don't break down under pressure, and its body contains a gel-like substance that's essentially incompressible. The fish has turned itself into a living, breathing piece of biological engineering that treats crushing pressure not as an obstacle, but as just another aspect of its environment. But that's just the beginning of the incredible adaptations we find down here. Crawling across the seafloor are creatures that look like they escaped from a science fiction movie. The giant amphipods, normally smaller than grains of rice at the surface, have grown to 13 inches long down here. 13 inches. They're pale white, almost translucent, with bodies that look like armored shrimp designed by an alien intelligence. These creatures have evolved what scientists call abyssal gigantism. They've grown to sizes that would be impossible in the surface world. And here's the really wild part. They have aluminum in their guts. Aluminum? Their digestive systems have evolved to concentrate this metal from the trace amounts in seawater, creating internal armor that helps them survive in this crushing environment. Scientists still don't fully understand why creatures grow so large in the deep ocean. Some think it's because the cold temperatures slow down their metabolism, allowing them to grow larger before reproduction. Others believe it's because food is so scarce down here that being big gives you an advantage in finding and processing the marine snow that falls from above. But whatever the reason, the result is creatures that look like they belong in the ocean of an alien planet. And speaking of alien appearances, let me tell you about some of the most bizarre organisms ever discovered on our planet. Scattered across the seafloor like living dinner plates are creatures called xenophyophores, single-celled organisms that have grown to 8 inches across. Think about that for a moment. These are single cells, just one cell, like the bacteria that cause strep throat or the yeast that makes bread rise, but they've grown to the size of dinner plates. They're the giants of the microbial world, and they exist nowhere else on Earth except in these abyssal depths. These incredible organisms spend their lives slowly crawling across the seafloor, feeding on the constant rain of organic matter that falls from the surface world. They're essentially living vacuum cleaners, processing the death and decay from the sunlit world above and transforming it into the foundation of the deep ocean's food web. When filmmaker James Cameron encountered fields of them during his historic dive in 2012, he described them as lunar and barren. Yet every one of these strange creatures was teeming with microscopic life. But perhaps the most remarkable creatures in this abyss are the ones that have learned to move through this crushing environment as if pressure were nothing more than a minor inconvenience. Sea cucumbers, animals that look like living sausages, inch along the seafloor at 35,000 feet below the surface, their bodies specially adapted with pressure-resistant proteins that allow them to function normally in conditions that would destroy any surface animal. These aren't just surviving down here, they're thriving, they're reproducing, they're feeding, they're carrying on complex behaviors in an environment so extreme it challenges our basic understanding of what life can endure. Some of them have been observed creating trails in the sediment as they search for food, leaving behind highways of biological activity that show this isn't a dead zone, but a living, breathing ecosystem. And then there are the bacteria. Oh, the bacteria. The sediment of the Mariana Trench is absolutely packed with microscopic life. Some of these bacteria produce compounds that glow with bioluminescence when disturbed, creating ethereal blue-green lights that dance across the seafloor like underwater aurora. Others have evolved to feed on chemicals that would be toxic to surface life: hydrogen sulfide, methane, and other compounds that seep up from the Earth's interior through cracks in the seafloor. These chemosynthetic bacteria have replaced photosynthesis with something even more remarkable: NDPOs. They've learned to create food and energy from the chemical wealth of the planet's interior. They're not dependent on sunlight at all. They've tapped directly into the chemical energy of the Earth itself, creating an ecosystem that could theoretically exist on any planet with liquid water and internal chemistry, regardless of whether that planet ever sees a star. But here's what really gets me excited about the life in the Mariana Trench, ATA. Almost every species down here exists nowhere else on Earth. Over 200 species have been identified living in these depths, and most of them are endemic to the trench system. They've evolved in complete isolation for millions of years, developing solutions to survival that are unique in the history of life on our planet. Each one of these creatures represents an independent experiment in evolution, a test of what's possible when life is pushed to the absolute extremes of existence. Some have evolved transparent bodies that make them nearly invisible in their dark environment. Others have developed specialized appendages for navigating in the crushing depths. Still others have evolved symbiotic relationships with the chemosynthetic bacteria, essentially farming microscopic organisms inside their own bodies. And we're still discovering new species all the time. Every deep-sea expedition brings back creatures that have never been seen before, organisms so strange and wonderful that they expand our definition of what life can be. In 2019, scientists discovered a new species of amphipod that produces antifreeze proteins to survive in the near-freezing water. In 2021, they found bacteria that can withstand radiation levels that would be lethal to any surface organism. But perhaps the most mind-blowing aspect of life in the Mariana Trench is how these creatures have learned to thrive, not despite the extreme conditions, but because of them. The crushing pressure that would obliterate surface life has become a necessary part of their biology. Some of the bacteria and other microorganisms actually require the high pressure to function. If you bring them to the surface, they die from decompression. Think about that. Creatures that die from experiencing the gentle pressure we consider normal. They're so perfectly adapted to the crushing depths that our world is as lethal to them as theirs would be to us. It's as if they've evolved on a different planet entirely, one where the laws of biology have been rewritten by the most extreme conditions Earth can offer. And the food web connections down here are just as remarkable as the individual organisms. The marine snow that falls from above supports the xenophyophores and sea cucumbers, which are then eaten by the giant amphipods, which in turn become food for the snailfish. But there are also chemosynthetic organisms that create food from the chemical seeps, supporting their own parallel food web that's completely independent of surface productivity. Some researchers believe the Mariana Trench might represent what early life on Earth looked like: organisms thriving in chemical-rich environments, independent of sunlight, powered by the chemical energy of the planet itself. If they're right, then studying these creatures isn't just about understanding extreme life. It's about understanding our origins, about seeing what life might have looked like in the earliest days of our planet, when the surface was hostile and the deep ocean was the only refuge for complex organisms. But there's something else about these creatures that absolutely blows my mind: their longevity. Because of the cold temperatures and slow metabolism, many of these organisms live far longer than their surface relatives. Some of the giant amphipods might live for decades. The xenophyophores could potentially survive for centuries. There might be organisms on the floor of the Mariana Trench that were already ancient when the first humans were learning to use tools. And they've all evolved these incredible adaptations completely independently, in isolation from the surface world, in an environment so stable that it's remained essentially unchanged for millions of years. While surface life has dealt with ice ages, asteroid impacts, and dramatic climate changes, the creatures of the Mariana Trench have lived in an environment so consistent that evolution could focus entirely on perfecting adaptations to extreme pressure and darkness. The result is a collection of organisms so perfectly adapted to conditions that seem impossible for life that they challenge every assumption we've ever made about the limits of biology. They've shown us that life isn't just resilient, it's incredibly creative, finding ways to thrive in environments that push the boundaries of what we thought was possible. But the most incredible part of this story isn't just that life exists in the deepest place on Earth. It's that humans have found the courage and ingenuity to visit this alien realm and witness these wonders firsthand. Because discovering the creatures of the Mariana Trench required some of the most daring and technically challenging expeditions in human history. Tomorrow, we're going to follow the brave explorers who risked everything to descend into this crushing abyss, to see what happens when human courage meets the most extreme environment on our planet, and to discover how their incredible journeys opened our eyes to a world we never knew existed right here on Earth. Are you ready to meet the humans who dared to visit the realm of these extraordinary creatures? Welcome back to our journey into Earth's ultimate abyss. We've met the incredible creatures that call the deepest place on our planet home, organisms so remarkable they seem like visitors from another world. But today, we're going to follow an even more remarkable story, the story of the handful of humans, brave enough, and perhaps crazy enough, to attempt the impossible journey to the bottom of the Mariana Trench. Picture this scene with me. It's January 23, 1960. The Cold War is at its peak, the space race is capturing headlines around the world, and everyone's looking up at the stars, dreaming of the day humans will walk on the moon. But on this day, two men are preparing for a journey that's arguably more dangerous and certainly more immediately achievable than anything NASA is planning. Jacques Piccard, a Swiss engineer and son of the famous balloonist Auguste Piccard, and Don Walsh, a U.S. Navy lieutenant, are about to squeeze themselves into what can only be described as the most claustrophobic space capsule ever designed. Their vessel, called Trieste, consists of a steel sphere just 6 feet across with walls 9 inches thick, attached to a massive float filled with gasoline. Now, you might be wondering, gasoline? In a submarine? That sounds insane, right? But here's the brilliant part. Gasoline is lighter than water, and unlike air, it doesn't compress under pressure. So as they descend and the crushing force of the ocean tries to implode their vessel, the gasoline float provides the buoyancy they need while staying relatively stable under the increasing pressure. The sphere itself is a marvel of engineering, essentially a pressurized capsule that has to maintain 1 atmosphere of pressure inside, while withstanding over 1,000 atmospheres of pressure outside. The math is terrifying when you really think about it. One miscalculation, one flaw in the steel, one weak spot in the construction, and these two men would be crushed to death in milliseconds. But they're going anyway. At 8 minutes past 10 in the morning, Trieste begins its descent into the Pacific Ocean southwest of Guam. Piccard and Walsh are crammed into their tiny sphere, surrounded by primitive instruments and controls that look like something from a 1950s science fiction movie. They have no way to communicate with the surface once they get deep enough. They have no way to be rescued if something goes wrong. They have only enough life support for a limited time on the bottom. They are essentially flying blind into the most hostile environment on Earth. The descent takes forever, and I mean forever. Unlike modern submersibles that can dive relatively quickly, Trieste sinks slowly, controlled by ballast weights and the careful management of their gasoline float. For the first hour, they can still see hints of sunlight filtering down through the water. By the second hour, They're in total darkness, relying entirely on their instruments to tell them where they are and how fast they're descending. At 32,000 feet below the surface, something happens that would have sent most people racing back to the surface, if they could. One of the viewing windows cracks with a sound like a gunshot, reverberating through their tiny metal sphere. Through their remaining porthole, they can see a spiderweb of fractures spreading across the thick acrylic window. Now, think about this for a moment. You're 6 miles underwater in a pressure capsule, and one of your windows just cracked. The rational thing to do would be to abort the mission immediately, drop your ballast, and pray you can make it back to the surface before the window gives way entirely. But Picard and Walsh decide to continue. They reason that the window was probably just adjusting to the pressure, that the crack might actually relieve stress rather than create a catastrophic failure point. It's a calculated risk that could easily be a fatal mistake, but they've come too far to turn back now. 4 hours and 47 minutes after leaving the sunlit surface, Trieste touches bottom at 35,797 feet below sea level. They have reached the deepest point on Earth, the bottom of Challenger Deep in the Mariana Trench. They are the first humans ever to visit the most extreme place on our planet. And what do they see when they look out their tiny porthole into the crushing darkness of the deepest place on Earth? A fish. Not just bacteria, not just simple microorganisms, but an actual fish, a flatfish similar to a sole or flounder, lying on the bottom and moving normally as if the crushing pressure were nothing more than a gentle breeze. In that moment, they prove something that scientists have been debating for decades. The complex life can exist in the deepest places on Earth. They stay on the bottom for 20 minutes. 20 minutes at the bottom of the world, in a place where no human had ever been before and where no human would return for over 50 years. They eat chocolate bars, take photographs through their cracked porthole, and try to absorb the magnitude of what they've accomplished. Then they begin their ascent, dropping ballast weights and rising through 7 miles of crushing ocean back toward the sunlit world they left behind. The return journey takes 3 hours and 15 minutes, faster than the descent because they no longer need to control their rate of fall. When they finally break the surface, they've completed one of the most remarkable journeys in human history. They've proven that humans can survive a descent to the deepest place on Earth, and more importantly, they've proven that life exists in places we thought were impossible for anything to survive. But here's what's really incredible. For the next 52 years, Jacques Picard and Don Walsh remain the only humans ever to visit Challenger Deep. 52 years. Think about that. In the same period, we put 12 people on the Moon, built the International Space Station, sent robotic probes to every planet in the solar system, and landed rovers on Mars. But only 2 people visited the deepest place on our own planet. Part of the reason is the sheer technical challenge. Building a vessel that can survive the crushing pressure of the deep ocean is incredibly difficult and expensive. But part of it is also that the deep ocean doesn't capture the public imagination the way space exploration does. We can all look up at the Moon and dream of walking there. The bottom of the Mariana Trench is invisible, hidden beneath miles of water, fundamentally alien in a way that's harder to romanticize. But in 2012, someone finally decided it was time to go back. James Cameron, yes, the filmmaker who directed Titanic and Avatar, spent years developing a new kind of submersible specifically designed to take a single person to the bottom of Challenger Deep. His vessel, Deep Sea Challenger, looked nothing like the bulky Trieste. Instead, it was designed like a vertical torpedo, painted lime green, with Cameron sitting in a pilot sphere at the bottom and all the scientific equipment and life support systems arranged above him. The engineering that went into Deep Sea Challenger was extraordinary. The pilot sphere was made from a new kind of syntactic foam that could withstand the crushing pressure while remaining light enough to be practical. The entire vessel was equipped with high-definition cameras, sample collection systems, and scientific instruments that would have been unimaginable in 1960. On March 26, 2012, Cameron squeezed into his vertical capsule and began his solo descent to the bottom of the world. Unlike Piccard and Walsh's leisurely 4-hour and 47-minute journey, Cameron's descent took just 2.5 hours thanks to his streamlined design and modern ballast systems. When he reached the bottom, Cameron spent 3 hours exploring the seafloor, more time than anyone had ever spent at the deepest place on Earth. He piloted his submersible across the bottom of Challenger Deep, filming with high-definition cameras and collecting samples of the sediment and any life forms he could find. His description of the bottom was hauntingly beautiful and profoundly lonely. He described it as lunar, desolate, as if no life existed. The bottom appeared to be covered with a fine, pale sediment, that marine snow we talked about earlier, accumulated over thousands of years into a soft carpet of death from the surface world. But when Cameron brought his samples back to the surface, scientists made an incredible discovery. That apparently lifeless sediment was absolutely teeming with microscopic life. In just one scoop of mud from the bottom of the Mariana Trench, researchers identified 68 new species of microbes, organisms that had never been seen before, perfectly adapted to the crushing pressure and eternal darkness of the deepest place on Earth. Cameron's dive proved that modern technology could not only reach the bottom of the Mariana Trench, but could do so safely and efficiently, opening the door for more extensive scientific exploration of these incredible depths. But the story doesn't end there. In 2019, explorer Victor Vescovo set a new depth record, reaching 35,853 feet in his submersible limiting factor, 56 feet deeper than anyone had ever gone before. Vescovo didn't just make one dive. He made multiple trips to the bottom, systematically exploring and mapping new areas of Challenger Deep. Vescovo's expedition used the most advanced deep-sea technology ever deployed, with a submersible designed to make repeated dives to full ocean depth. His team created the most detailed maps ever made of the deepest parts of the Mariana Trench, revealing underwater mountains, valleys, and geological formations that had never been seen before. But Vescovo's expedition also made a discovery that broke the hearts of everyone involved in deep-sea exploration. At the bottom of the world, in the most remote and pristine place on our planet, they found human garbage. A plastic bag and candy wrappers sitting on the seafloor of Challenger Deep like monuments to humanity's reach. Think about that for a moment. Our pollution has reached literally every corner of our planet, from the peak of Mount Everest to the bottom of the Mariana Trench. There is nowhere on Earth so remote that human influence hasn't touched it. But these expeditions have also revealed something profoundly hopeful. Iron Age, incredible resilience and adaptability of life itself. Every dive to the deep ocean reveals new species, new forms of life that have found ways to thrive in conditions that seem impossible. These organisms represent millions of years of evolution, millions of years of life pushing the boundaries of what's possible. The humans who have dared to visit the Mariana Trench, Piccard, Walsh, Cameron, Vescovo, and the small handful of others who have made this incredible journey, have opened our eyes to a world we never knew existed. They've shown us that our planet still holds mysteries that rival anything we might find in outer space. Their courage and ingenuity have revealed that the deepest place on Earth isn't a dead zone, but a thriving ecosystem, that life finds a way even in the most extreme conditions our planet can offer, and that there are still frontiers left to explore right here on our own world. But perhaps their most important discovery was this: the bottom of the Mariana Trench isn't just a place of scientific curiosity. It's a mirror that reflects back to us both the incredible power of life to adapt and survive, and the sobering reality of humanity's impact on even the most remote corners of our planet. Tomorrow, we're going to explore the incredible discoveries that these brave explorers made possible, revelations that have changed our understanding of life, our planet, and our place in the cosmos. Because the bottom of the Mariana Trench has secrets to tell us. Secrets that will reshape how we think about life itself. Are you ready to discover what the abyss has taught us about our world? Welcome back to our exploration of Earth's ultimate abyss. We've followed the brave humans who dared to visit the bottom of the world, and now we're going to discover what their incredible journeys revealed. Discoveries so profound, they've rewritten our understanding of life, our planet, and even our search for life beyond Earth. The first shock came in 1960, when Jacques Piccard and Don Walsh spotted that flatfish through their tiny porthole. That single observation, a fish swimming normally at the bottom of the deepest place on Earth, instantly demolished decades of scientific assumptions. Textbooks had stated with absolute certainty that complex life was impossible at such depths. The pressure was too extreme, the conditions too hostile, yet there it was, living proof that life finds a way even in the most impossible places. But that was just the beginning. The real revelations began when modern technology allowed scientists to bring samples back from the abyss and study them in detail, and what they discovered challenged everything we thought we knew about the limits of life on our planet. In 2005, researchers made a discovery that sounds like science fiction. They collected tiny microbes from sediment in Challenger Deep and brought them to the surface. Now, logic suggested that organisms adapted to crushing pressure would die when exposed to the relatively gentle pressure of the surface world. Instead, something incredible happened. The microbes didn't die. They went dormant. Think about that for a moment. These organisms, perfectly adapted to pressure 1,000 times greater than what we experience at sea level, could survive the journey to our world. But when scientists recreated the crushing pressure of the deep ocean in their laboratories, the microbes came back to life, thriving once again in conditions that would obliterate any surface organism. This wasn't just survival, this was a completely different way of being alive. These microbes had evolved to use pressure as a necessary component of their biology. They weren't just tolerating the crushing depths, they required them to function properly. It was as if scientists had discovered organisms from a different planet entirely, one where the basic requirements for life had been completely reimagined. But the revelations kept coming. The deep-sea organisms weren't just surviving in the absence of sunlight, they had developed an entirely different approach to creating food and energy. Instead of photosynthesis, which converts sunlight into chemical energy, these creatures use chemosynthesis, IM, the process of creating food from chemicals. Some of the bacteria living in the Mariana Trench consume hydrogen and methane that seep from the Earth's interior through cracks in the seafloor. Others feed on hydrogen sulfide and other compounds that would be toxic to surface life. They've tapped directly into the chemical energy of the planet itself, creating an ecosystem that's completely independent of the Sunday. This discovery has profound implications for our understanding of life on Earth, and potentially life throughout the universe. These organisms prove that life doesn't need sunlight to thrive, it just needs chemical energy. And chemical energy exists on planets and moons throughout our solar system, places where sunlight is weak or non-existent, but where liquid water and chemical reactions create the potential for life. In 2014, scientists made another remarkable discovery about the water at the bottom of the Mariana Trench. They expected it to be uniformly cold, maybe a degree or two above freezing like most of the deep ocean. Instead, they found that the water at the very bottom is actually slightly warmer than the water above it. This might not sound like a big deal, but it revealed something incredible about the geology of the trench. The bottom water is being heated by the Earth's interior, by the friction of grinding tectonic plates, and by geothermal energy from deep within our planet. The deepest place on Earth is warmed by the planet itself, creating temperature gradients and chemical conditions that exist nowhere else. These temperature differences drive circulation patterns that bring nutrients and chemicals up from the Earth's interior, creating a dynamic, ever-changing environment at the bottom of the abyss. It's not a static, dead place. It's geologically active, chemically rich and constantly being renewed by the forces that created it. But perhaps the most important discovery came from studying sediment cores, etc., long cylinders of mud and debris extracted from the seafloor. These cores revealed that the Mariana Trench acts as a massive carbon trap, storing organic matter for millions of years and affecting global climate cycles. Every piece of marine snow that falls from the surface world, every fragment of dead plankton and organic debris, gets concentrated and preserved in the deep sediments of the trench. Over geological time, this process removes carbon from the surface world and locks it away in the deep ocean, influencing the planet's climate in ways we're only beginning to understand. The trench isn't just a geological feature, it's an active participant in the Earth's climate system, helping to regulate the chemistry of our oceans and atmosphere over timescales of millions of years. But then came discoveries that were both incredible and heartbreaking. In 2017, scientists studying amphipods from the deepest parts of the Mariana Trench made a disturbing discovery. These creatures, living in what should be the most pristine environment on Earth, contained PCB pollutants, HAOs, chemicals that were banned in the 1970s. Here's what's truly shocking. The concentrations of these pollutants in the deep-sea amphipods were 50 times higher than levels found in China's most polluted river. 50 times. How is that even possible? The answer reveals something profound and troubling about the interconnectedness of our planet's systems. Pollutants from the surface world don't just disappear. They accumulate in the marine snow that falls constantly to the deep ocean. As this contaminated debris settles and concentrates over decades, it creates pollution, hotspots, in the most remote places on Earth. The amphipods, feeding on this rain of contaminated organic matter, bioaccumulate these toxins to concentrations far higher than anything found in the surface world. The deepest, most remote place on our planet has become a concentration zone for humanity's chemical legacy. In 2019, the news got even worse. Every single amphipod tested from the Mariana Trench contained microplastics, tiny fragments of plastic pollution that have infiltrated every corner of our planet's ecosystems. Even at the bottom of the world, in a place that should be untouched by human influence, these creatures carry the microscopic debris of our plastic civilization in their bodies. This discovery was a sobering reminder that there is no place on Earth so remote that human activity hasn't affected it. Our influence has reached literally every corner of our planet, from the peak of Mount Everest to the bottom of the Mariana Trench. But the discoveries weren't all sobering. Scientists also found that the trench generates its own earthquakes, deep focused tremors happening 400 miles down, deeper than anywhere else on Earth. At those depths, the rock should be too hot and soft to crack and generate earthquakes, yet somehow it does. These deep earthquakes reveal that the Mariana Trench is more geologically active than anyone expected. The descending Pacific plate continues to fracture and adjust even after it's been pushed hundreds of miles into the Earth's interior, generating seismic activity that helps drive the chemical processes that make life possible in the deep ocean. Recent discoveries have revealed that the trench is also volcanically active in ways we never expected. Underwater eruptions that we've never directly witnessed create new seafloor formations and release chemical-rich water that supports unique ecosystems. Some of these volcanic features create their own localized environments with different temperatures, pressures, and chemical conditions. But perhaps the most profound revelation from studying the Mariana Trench is what it's taught us about the possibility of life beyond Earth. The organisms thriving in the crushing pressure and eternal darkness of the deep ocean provide clues about what life might look like on Europa, Jupiter's ice-covered moon, or Enceladus, Saturn's frozen satellite. Both of these moons hide vast oceans beneath their icy surfaces, oceans that are completely cut off from sunlight but rich in chemical energy from their planetary interiors. The life forms we've discovered in the Mariana Trench show us that such environments could potentially support complex ecosystems, even without any connection to solar energy. The chemosynthetic bacteria and pressure-adapted organisms of the deep ocean are essentially living prototypes for what alien life might look like. They've shown us that life doesn't need the conditions we consider normal. It can thrive in environments that seem hostile and impossible. Every new dive to the Mariana Trench reveals new mysteries that challenge our understanding of our planet. Strange sounds recorded in 2014 remain unexplained, low-frequency noises that seem to emanate from the deepest parts of the trench, unlike anything heard anywhere else in the ocean. Some scientists speculate these sounds might be created by geological processes we don't understand yet, perhaps the movement of sediment under pressure, or chemical reactions happening in the deep seafloor, or even biological activity from organisms we haven't discovered yet. The trench continues to yield surprises that redefine our understanding of what's possible on our planet. Recent expeditions have discovered new forms of mineral formations created by the extreme pressure and chemical conditions, some of which might have applications in materials, science, and engineering. Scientists have also found evidence of biological processes that shouldn't be possible, according to our current understanding of biochemistry. Aerobia, organisms that seem to violate the basic rules of metabolism and energy production that govern all surface life. But perhaps the most important revelation from decades of studying the Mariana Trench is this: our planet still holds secrets that rival anything we might discover in outer space. We've spent so much energy and resources looking up at the stars, searching for signs of life in the cosmos, that we've neglected the alien worlds that exist right here on Earth. The Mariana Trench has shown us that life is far more resilient, adaptable, and creative than we ever imagined. It's revealed that our planet operates on cycles and systems that span millions of years, connecting the deepest ocean trenches to global climate and chemical processes in ways we're only beginning to understand. Most importantly, it's shown us that exploration and discovery aren't just about satisfying human curiosity, they're about understanding our place in a living, dynamic planet that continues to surprise and amaze us with its complexity and beauty. The revelations from the Mariana Trench have changed everything we thought we knew about life, our planet, and our impact on the world around us. But they've also opened up incredible possibilities for the future: new technologies, new understanding of life's potential, and new frontiers for exploration that could reshape our understanding of what's possible. Tomorrow, we're going to explore those possibilities and discover how the lessons learned in the deepest place on Earth are pointing us toward an incredible future of exploration and discovery. Are you ready to glimpse the future that the Mariana Trench has revealed? Welcome back to our final chapter in this incredible journey to the deepest place on Earth. We've explored the alien landscape of the Mariana Trench, met its extraordinary inhabitants, followed the brave humans who dared to visit this crushing abyss, and discovered the profound revelations that have changed our understanding of life itself. Now, let's look toward the future and explore what tomorrow holds for our exploration of Earth's ultimate frontier. Here's a fact that should absolutely blow your mind. Right now, today, we have mapped more of the surface of Mars than we have of our own ocean floor. Think about that for a second. We've sent satellites and rovers to a planet that's, on average, 140 million miles away from Earth, and we know more about its geography than we do about the seafloor of our own planet. Only 20% of the Mariana Trench has been explored. 20%. That means 80% of the deepest, most extreme place on Earth remains completely unknown to us. We're living on a planet where vast underwater mountain ranges, deep valleys, and entire ecosystems exist in places no human eye has ever seen. But that's about to change in ways that would have seemed like science fiction just a decade ago. Right now, at research institutions around the world, engineers are developing autonomous underwater vehicles that can dive for 72 hours continuously, using artificial intelligence to identify interesting features and collect samples without any human guidance. These aren't just remote-controlled submarines, they're intelligent explorers that can make decisions about what to investigate, how to navigate around obstacles, and what samples to collect. Vehicles like Kaiko, Nereus, and their successors are getting more sophisticated every year. The latest generation can operate at full ocean depth, navigate using sonar and artificial intelligence, and even communicate with each other to coordinate their exploration efforts. Imagine swarms of these autonomous explorers systematically mapping every valley, every cliff face, every strange geological formation in the Mariana Trench. But the real breakthrough is happening in the laboratories where scientists are learning to extract DNA directly from sediment samples. They're discovering thousands of species without ever seeing the actual organisms, just by reading the genetic signatures they leave behind in the mud of the deep ocean floor. These genetic libraries are revealing a diversity of life in the deep ocean that we never imagined. Every scoop of sediment contains the genetic fingerprints of dozens or hundreds of species, many of them completely unknown to science. We're essentially reading the biological history of the deep ocean, discovering new forms of life by decoding the genetic information they've left behind. And some of these discoveries are pointing toward applications that could revolutionize industries and medical treatment. Organisms that thrive under extreme pressure produce enzymes and compounds that could have incredible industrial applications. Imagine manufacturing processes that use enzymes evolved to work under crushing pressure, or materials science applications based on the pressure-resistant proteins found in deep-sea fish. Scientists have discovered bacteria in the Mariana Trench that produce compounds capable of breaking down toxic pollutants, IPA, organisms that could potentially be used to clean up contaminated sites that are currently considered impossible to remediate. Life forms that have evolved to process the most extreme chemical environments on Earth might hold the keys to solving some of our most challenging environmental problems. But the most ambitious projects for exploring the Mariana Trench are still to come. Japan has announced plans for a deep-sea research station by 2030, a permanently staffed facility where aquanauts will live at depth for months at a time, conducting continuous research in the deep ocean environment. Picture this: humans living and working in the abyss, not just visiting for a few hours, but actually establishing a permanent presence in the deepest parts of our planet. This research station would allow for long-term studies of deep-sea ecosystems, continuous monitoring of geological processes, and the kind of detailed scientific work that's impossible to accomplish during brief diving expeditions. China's Rainbow Fish project has set an even more ambitious goal, to explore all ocean trenches by 2035. Not just the Mariana Trench, but every deep ocean trench on Earth. They're developing a fleet of deep-sea vehicles capable of systematic exploration and mapping of these extreme environments. This isn't just about scientific curiosity, it's about understanding how these deep ocean systems affect global climate, ocean circulation, and the chemistry of our planet's water. The trenches aren't isolated features. They're connected to global systems that influence weather patterns, carbon cycling, and the overall health of our oceans. But there's also a more controversial aspect to the future of deep-sea exploration, I-5, commercial mining. Private companies are beginning to eye the Mariana Trench and other deep-sea environments for rare earth minerals and other valuable resources. The seafloor contains vast deposits of metals and minerals that are essential for modern electronics and renewable energy technologies. The challenge is that mining these resources would likely destroy ecosystems that have taken millions of years to develop. Many of the organisms we've discovered in the Mariana Trench exist nowhere else on Earth. They're the products of millions of years of evolution in isolation. Mining operations could wipe out entire species before we even have a chance to study them. It's a classic conflict between economic opportunity and environmental protection, but with stakes that are particularly high because we're dealing with ecosystems that are irreplaceable and largely unexplored. How do we balance the potential benefits of accessing these mineral resources against the risk of destroying unique forms of life that might hold keys to medical breakthroughs or our understanding of life itself? But perhaps the most exciting aspect of future Mariana Trench exploration is its connection to astrobiology, e.g., the search for life beyond Earth. The organisms thriving in the extreme conditions of the deep ocean provide our best models for what life might look like on other worlds. Europa, Jupiter's ice-covered moon, hides an ocean beneath its frozen surface that contains more water than all of Earth's oceans combined. Enceladus, Saturn's frozen satellite, has geysers of water shooting through cracks in its ice shell, revealing a subsurface ocean that's been liquid for millions of years. These alien oceans exist in complete darkness, under crushing pressure, and at temperatures near freezing, conditions remarkably similar to what we find in the Mariana Trench. The life forms we've discovered in Earth's deepest abyss show us that such environments could potentially support complex ecosystems. The chemosynthetic bacteria, the pressure-adapted fish, the giant amphipods, they're all prototypes for what alien life might look like. Future missions to Europa and Enceladus will carry instruments designed based on what we've learned from studying life in the Mariana Trench. The techniques we've developed for detecting life in extreme environments here on Earth will guide our search for life in the dark oceans of other worlds. But there are still so many mysteries waiting to be solved right here in our own planet's deepest abyss. Those strange sounds recorded in 2014 remain unexplained, low-frequency noises that seem to emanate from the deepest parts of the trench. Are they geological, biological, or something else entirely? Recent mapping has revealed underwater volcanic activity that suggests eruptions we've never witnessed. These volcanic processes create new seafloor formations and release chemical-rich water that could support ecosystems we haven't discovered yet. Future expeditions will need to explore these active volcanic zones to understand how they contribute to the unique chemistry and biology of the deep ocean. Scientists are also discovering that the trench's role in global climate systems is more complex than they initially understood. The way it traps carbon, processes organic matter, and influences deep ocean circulation patterns affects the entire planet's climate system. Understanding these connections could be crucial for predicting and responding to climate change. Advanced genetic sequencing techniques are revealing that the diversity of microbial life in the Mariana Trench is orders of magnitude greater than anyone expected. Every new sample contains genetic signatures from organisms that have never been seen or studied. We're essentially discovering new branches on the tree of life with every expedition. Some researchers believe we might find organisms in the deepest parts of the trench that represent entirely new domains of life, forms of organization that are fundamentally different from bacteria, archaea, and the complex cells that make up plants and animals. If such discoveries are made, they would rewrite biology textbooks and expand our understanding of what life can be. The technology being developed for Mariana Trench exploration is also pushing the boundaries of materials science and engineering. Creating vessels that can withstand crushing pressure while remaining light enough to be practical requires innovations in metallurgy, composite materials, and structural design that have applications far beyond deep-sea exploration. Some of these technologies are already finding their way into other fields: pressure-resistant materials for aerospace applications, ultra-efficient communication systems for remote environments, and energy systems that can operate reliably under extreme conditions. But perhaps the most profound impact of future Mariana Trench exploration will be on our understanding of our own planet and our place in the cosmos. The trench represents the last unexplored frontier on Earth, a place that's more alien than the surface of Mars but accessible with current technology. As we map every valley, catalogue every species, and understand every geological process in the deepest places on Earth, we'll complete our picture of our own planet's diversity and complexity. We'll understand how the most extreme environments on Earth connect to global systems, how life pushes the boundaries of what's possible, and how our planet continues to surprise us with its ingenuity and resilience. The Mariana Trench has already shown us that life is more adaptable, more creative, and more resilient than we ever imagined. It's revealed that our planet operates on systems and cycles that connect the surface world to the deepest abyss, that pollution can reach even the most remote places, and that there are still frontiers for exploration and discovery right here on our own world. As we stand at the threshold of a new era of deep ocean exploration, equipped with artificial intelligence, advanced materials, and sophisticated genetic analysis tools, we're about to unlock secrets that have been waiting in the crushing darkness for millions of years. The Mariana Trench isn't just the deepest place on Earth, it's a window into our planet's past, a laboratory for understanding life's potential, and a gateway to exploring the possibilities for life throughout the universe. The future of deep-sea exploration promises to reveal wonders that will reshape our understanding of life, our planet, and our place in the cosmos. The abyss still has secrets to tell us. The deepest frontier on Earth is waiting to be explored, and the most incredible discoveries about our own planet may still be lying in the crushing darkness, 7 miles below the surface of the sea. Thank you for joining me on this incredible journey to the bottom of the world. The Mariana Trench has shown us that our planet still holds mysteries as profound as anything we might find among the stars, and that the most alien world in our solar system might be right here, hidden beneath the waves of our own ocean. The deep is calling, and humanity is finally ready to answer.